Alright, so I'm going to go over this review that you guys have for homework and just for your preparation for the test. Alright, so let's get started with the first few, right? So you're going to have problems where you'll have to simplify, multiply, divide rational expressions, right? So this is going to cover P5ab and 1.2ab, right? So you still need to know how to simplify, multiply, and divide rational expressions, right? Something like this one's going to be pretty simple, right? We just have a monomial over a monomial, right? So this one we just need to find a common factor and cancel it out, right? So between 30 and 42, right, cancel these out. You can divide them both by 6, right? 30 divided by 6 is 5. 42 divided by 6 is 7. All right, and then as far as the n to the fifth and the n to the third, right, there's 3 n's on the bottom, 5 on the top. We can cancel out 3, right? And when we take out 3 from the top and on the bottom, we have no n's on the bottom, but we have 2 on the top. All right, so we have 5n squared, right, as this answer. All right. And then something like number 2, right? So number 2, you just want to factor, right? We have a binomial over a binomial, right? R minus 4 doesn't factor at all, right? 5r minus 20, you can take out a GCF, right? And you can take out a GCF of 5, and you're left with 5 times r minus 4, right? And then what cancels here is the r minus 4. All right, so then you're just left with a 5 on the bottom, and there's nothing left on the top, so we write a 1, right? Don't make the mistake of just writing 5, right? So if everything cancels except for the bottom, right, you still need to write it on the bottom. If it was there originally, it needs to stay there, right? So this one's going to be 1 over 5, all right? And then something like number 3, right, we're still simplifying here, right? But it looks a little bit bigger than the others, right? But it's nothing crazy here. We just want to factor, right? P squared minus 12p plus 27 factors, right? So this is going to become p minus 3, right? And then p minus 9, right? So you're asking what multiplies to 27 and adds to negative 12, right? And it's negative 3 and negative 9. So p minus 3, p minus 9. And then on the bottom, you can take out a GCF of 3, right? So when you take out the 3, you're left with a p minus 9. All right, and then what cancels here is the p minus 9, right? P minus 9 cancels, so on the top, you're just left with the p minus 3. And on the bottom, you're left with just a 3. All right. And then the next one's another factoring one, right? Factor everything and then cancel anything that is the same on the top and on the bottom, right? So we want to factor the top, take out a GCF, right? We get 5 times m plus 8. And on the bottom, we can factor m squared plus 9m plus 8, right? What multiplies to 8 and adds to 9 is going to be 1 and 8. All right, so m plus 1, m plus 8. And then what cancels on the top and on the bottom is this m plus 8. All right, so we're just left with a 5 over m plus 1. All right, and now we start multiplying expressions, right? These shouldn't be any more difficult, right? The easiest way that I like to do these, I like to simplify each of these fractions first and then cross cancel, I'm sorry. Right, so 13y to the 5th over 5x to the 4th, nothing simplifies there. But 4x squared over 8y cubed, right? We can simplify the 4 and the 8 to become a 1/2. All right. All right, so those go away. We're just left with a 1/2. And then now we can cross cancel, right? So something here cancels, right, between 5x to the 4th and 1x to the 4th, or 1x to the 2nd. Right, what cancels here are 2 x's on the top and on the bottom, right? So we can take out 2 x's on the top, 2 x's on the bottom, right? So we're left with just 2 x's on the bottom. All right, and then here we can also cross cancel, right? Between 13 and 2, nothing cancels, right? But between y to the 5th and y to the 3rd, you can take out 3 y's from the bottom, 3 y's from the top, you're left with 2 y's on the top, right? So then you just multiply straight across. 13 times y squared times 1 is just 13y squared over 5 times x squared times 2 is going to be 10x squared. All right. Similar story with number 6, right? Threw in a little extra variables here, right? But essentially the same thing, right? You just want to cancel anything that cancels. Again, I'll start in this side, and you'll notice that an x cancels, right? And then I'll move on to this side, right? You'll notice that an x squared cancels, right? And there's 1y on the top, 2y's on the bottom. You can take out 1 from the top and on the bottom, so you're just left with 1y on the bottom, right? So let me just rewrite what we have here, right? So we have a 9y to the 4th over 7, and this is times 2 over 7y, right? So this is what we have so far, and now we begin cross-canceling, right? So everything on the top, everything on the bottom, we just want to see what cancels, right? So what can cancel with this y on the bottom is 1y on the top, right? So we take out 1y from 4y's, we're just left with 3y's. All right, so then our final answer should be 9y cubed times 2 is going to be 18y cubed. And then the bottom, 7 times 7 is just 49. All right, let's keep going. Right, so we have some more multiplying ones. Right, I find that a lot of kids find these a little bit easier because we're kind of drilling factoring into your head, right? So hopefully you should notice that something like this is going to factor, right? N squared minus 6n minus 7, right? So what multiplies to negative 7 and adds to negative 6 is going to be negative 7 and negative 1. Or positive 1, I'm sorry. All right, and then now that everything's factored, you just see what cancels on the top, what cancels on the bottom, right? N minus 7 cancels, and n plus 1 cancels, right? There's an n plus 1 on the top and on the bottom. The only thing that you're left with here is an n minus 4. All right. And now number 8 as well, right? You're just looking. Everything on the top has to factor, and everything on the bottom has to factor, right? So m squared plus m minus 72. Keep in mind, when there's no variable, when there's no coefficient, we assume it's a 1. Right, so what multiplies to negative 72 and adds to positive 1 is going to be m plus 9, m minus 8. All right, and you're going to do the same thing on the bottom. All right, so m squared minus 14m plus 48, what multiplies to 48 and adds to negative 14 is going to be m minus 8, m minus 6. All right. Now that everything's factored, you just want to see what cancels on the top and on the bottom, right? There's an m plus 9 that cancels, and there's an m minus 8 that cancels, right? So on the top, you're just left with an m minus 4. On the bottom, you're left with an m minus 6. All right, and there's your final answer. All right, and now when we get to division, right? Division problems are going to work very similarly to multiplication problems. Just the only thing that you have to do first is you have to keep, change, flip, right? Keep the first, change division to multiplication, and then you flip the last fraction, right? So let me just rewrite this problem in its keep, change, flipped form, right? So we get n squared plus 10n plus 9 over n squared plus 7n plus 6, right? And then change division to multiplication, so times 7 over n plus 9. All right, and now let's factor everything, right? N squared plus 10n plus 9, right? What multiplies to 9 and adds to 10, this is just going to be n plus 9, n plus 1. All right, and then the same thing on the bottom. What multiplies to 6 and adds to 7? All right, we're going to do n plus 6, n plus 1. All right, now that everything's fully factored, let's start canceling. N plus 1 is going to cancel, n plus 9 is going to cancel. All right, so then we're just left with a 7 on top, and then we're just left with an n plus 6 on the bottom. All right. And then this one right here is going to be another division, right? So we're going to keep, change, flip, right? So keep the 9, right? 4k minus 8k squared. Change division to multiplication and flip the last one. So 8k squared minus 4k over k minus 3. All right. And then, I always tell you guys to factor everything, but just look at what you have here. All right. Notice that the 8k squared minus 4k is similar to 4k minus 8k squared, right? So We went over a couple examples like these, right? So if you see everything on the top is the same as everything on the bottom, they just have opposite signs, which is the case here, right? This 8k squared is positive, down here it's negative. Up here the 4k is negative, down here it's positive. Then you can still cross them out. They just become -1. All right. And then nothing else cancels here, right? So we just get 9 times -1 is -9 over k minus 3. All right. Okay, good. And then that's all from section P5, A and B, right? So those are here for your practice, right? And then everything in this review onwards is going to be section or chapter 1.2, A and B, right? So you'll get some simple ones like these, right? Where you're just solving for the given variable, right? So we have a -8a minus 32 equals 8 times a -2a plus 1. We just want to distribute the 8 to everything, right? We're solving this as normal, right? This is essentially an Algebra 1 problem, right? Equals distribute 8 to -2a is going to be -16a. And then distribute 8, we get plus 8, right? And then we want to get the a's to one side, right? So let's add 16a. And let's get the constants on the other, right? So let's add 32. Right, so then -8a plus 16a is going to be 8a equals 8 plus 32 is 40. Right, and then divide both sides by 8. We should get a equals 5. All right, same thing with number 12. Right, we see parentheses and a number in front, so let's distribute the 7. Right, so then everything else stays the same. We get -3 plus 7 plus 21x equals 4 plus 7x. All right, and now let's combine like terms, right? -3 plus 7 is 4, and then plus 21x equals 4 plus 7x. All right, and now let's get the x's to one side and the constants on the other. Let's move -7x to the other side, and then let's move 4 to the other side. All right, so -7x cancels, and then 4 cancels here, but 4 also cancels here. So here we're just left with 14x equals 0. Now when you see the 0, don't freak out and say no solution, right? Or say all real solutions, all real numbers, right? You're not always going to get a crazy case like that when you get x equals 0, right? You have to actually finish this problem, right? So let's do 14x equals 0, right? Again, it's not going to be a no solution. It's not going to be in all real numbers, right? You have to actually finish it and see what you get, right? Because when you divide both sides by 14, right, you get x equals 0 divided by 14. Is this allowed? Yes, it is, right? 0 over anything is just 0, right? So we get x equals 0 as our answer. All right, good. And now let's try number 13, right? So again, we have parentheses and something in front of it, so let's distribute this negative to each term inside the parentheses. All right, so -11 plus 6n stays the same. All right, equals 5n. Right, so this negative is just going to change the sign of everything on the inside, right? So it becomes -1 plus 3n. All right, now that we got rid of the parentheses, all right, combine like terms. All right, so 5 plus 3n is going to be 8n. Minus 1 equals -11 plus 6n. And then get all the variables to one side, all the constants on the other, right? So let's subtract 8n, and let's add 11. All right, so 6n minus 8n is going to be -2n, and then -1 plus 11 is going to be 10. And then the last thing you want to do is divide both sides by -2. All right, so then you get n equals 10 divided by -2 is -5. All right, so let's keep going with these. Right, so something like number 14 should be way easier, right? So here, all we have to do is combine like terms, right? 4x plus 6x should get you 10x, and this equals -10. All right, and then divide both sides by 10, right? And then -10 divided by 10 is just -1, right? So x equals -1. All right, same thing with number 15, right? Should be a little bit simpler, right? All you have to do is combine like terms, right? So we see a -x minus 4x, right? Keep in mind this -x is the same as a -1x, right? So negative 1x minus 4x is going to be negative 5x. All right, and then everything else stays the same for now, right? So plus 5 equals 15. All right, and so now let's subtract the 5. So then we're left with negative 5x equals 15 minus 5 is 10. All right, and then the last thing you want to do, divide both sides by negative 5. All right, so that cancels out, and so we get x equals 10 divided by negative 5 is negative 2. All right, and then we get into some problems with fractions, right? So these are some of the easier fraction problems, right, where you just have whole numbers in the denominator, right? So with these, you want to find a least common multiple between 4, 3, and 2, right? Think about that for a minute. Between 4, 3, and 2, the least common multiple should be 12, right? And multiplying by the least common multiple, right, multiplying this entire equation by the least common multiple is going to cancel out all of our denominators, right? So let's distribute negative 12, right? So this should get you an equation like negative 7 times 12 over 4 equals 7 times 12 over 3a, right? And then plus 1 times 12 is 12, and then minus 1 times 12 again is 12 over 2a. All right, and then simplifying all these fractions eliminates the denominator. All right, so notice that I didn't go ahead and do, okay, negative 7 times 12, 84, or negative 84. Negative 7 times 12, 84 divided by 3, right? You don't really want to do that because the 12 and the 4 are going to simplify, right? So give yourself easier numbers to work with, right? So 12 divided by 4 gets you 3. So when you replace it with 3, right, that might save you a little bit of time as opposed to doing negative 84 divided by 4. Or same thing here, right? Simplify the 12 and the 3, right? That becomes 4, right? 7 times 4 is much easier to do than 84 divided by 3, right? So again, work a little bit smarter, right? You don't need to do 84 divided by 3 when you don't need to, right? There's an easier way to do it. All right, and then negative 12 divided by 2 simplifies to negative 6. All right, so now that we have all of our denominators gone, all right, let's do negative 7 times 3 is negative 21. And then this equals 7 times 4a is going to be 28a. And then plus 12 minus 6a. All right, and then just like the others, we want to combine like terms. All right, so 28a minus 6a is going to be 22a. Plus 12 equals negative 21. All right, and then you subtract the 12 on both sides. And then you get negative 33 equals 22a. All right, and then divide both sides by 22. All right, and then 33 divided by 22 simplifies, right? So a equals, you can divide an 11 from both of them, negative 3 over 2. All right, and let's do the same thing with number 7, right? So the least common multiple between 10, 6, and 5, right, should be 30. All right, so let's multiply this entire equation by 30. Distribute 30 to everything. And then again, I'm not going to do 30 times 41 and write out that whole thing, right? Whatever that is, I don't even know what that is, right? So work a little bit smarter, right? So do negative 41 times 30 over 10 and then simplify, right? And then we get 30 over 6a and then plus 6 times 30 over 5a, right? And now let's simplify all these fractions. All right, 30 and 10 simplify, it becomes 3. Right, 30 and 6 simplify becomes 5. And then 30 and 5 simplify becomes 6. Right, so we're left with negative 41 times 3 equals 5a plus, and then 6 times 6 is 36a. Right, and then notice negative 41 times 3 might be a little bit easier to do than negative 41 times 30 and then dividing it by 10, right? It's essentially the same thing, right? You just add a 0 at the end, but, right, it might look a little bit less intimidating, right? So you do this and it should get you, I believe, negative 123, right? So negative 123 equals, and then combine like terms here, right? So 5a plus 36a should get you 41a. And then now we want to divide both sides by 41. All right, so then we get a equals negative 123 divided by 41, right? But remember, we kind of just did this, right? We did negative 41 times 3 got you negative 123, and we're dividing by the same number, right? So then in this case, we get a equals negative 3. All right. Okay, cool. And then number 18 again, right? Between 5, 3, and 6, we want to find a least common multiple, right? And in this one, again, this one's also going to be 30, right? So let's multiply this entire expression by, or this entire equation, sorry, by 30. All right, so we should get negative 12 times 30 divided by 5x, and then plus 11 times 30 over 3x equals negative 19 times 30 divided by 6. Right, so just like the last one, you don't want to do negative 12 times 30 and get negative 360 and then divide, right? That's a little too much for this one, right? You are able to simplify these fractions first, right, before you go ahead and multiply, right? 30 and 5 simplify to 6, right? 30 and 3 multiply to 10, or simplify to 10. And then 30 and 6 simplify to 5. All right, and then this is much easier to deal with than if we were to do, okay, negative 360 divided by 5, right, 330 divided by 3, and so on, right? So here we're just left with negative 12 times 6 is negative 72x, all right, and then plus, all right, 10 times 11x is going to be 110x, and this equals negative 19 times 5 is negative 95. All right, and then negative 72 plus 110, all right, I believe that should get you 38x, right? Yeah, 38x. And this equals negative 95. And then divide both sides by 38. Divide by 38. All right, cancel out the 38. We get x equals negative 95 over 38. Right, and then here, right, it might not be super obvious, but you can check and verify that these numbers share a common factor of 19, right? So cross these out, divide them both by 19, right? You should get x equals negative 5 over 2. All right, this should be your answer. Okay, good. And now we move on to ones where you have variables in the denominator, right? So these essentially work the same as all the other ones, right? You just need to ask yourself, what can you multiply this entire equation by to eliminate all the denominators, right? So I would ask you in class, right, what do we need to multiply x minus 5 over x squared by to get rid of the x squared? And that answer is x squared, right? X squared divided by x squared cancels out. Same thing with this 1x squared, right? 1x squared times x squared is going to cancel out. And then with this one right here, we need to multiply a 3x squared, right? So I'm going to multiply this entire equation by 3x squared, right? As little factors as possible to eliminate all the denominators, right? So distribute this 3x squared everywhere. And then we're left with a 3x squared times x minus 5 over x squared equals, and then 3x squared times 1 is 3x squared over x squared, and then plus 3x squared times x plus 4 over 3x squared. All right, and now you want to simplify all these. Remember, the whole point of multiplying by 3x squared is to eliminate the denominator. All right, so x squared and x squared cancel out, x squared and x squared cancel out, 3x squared and 3x squared cancel out. All right, so you're just left with the 3 times x minus 5 equals 3 plus x plus 4, right? And now we just solve as normal, right? Distribute this 3, combine the like terms, we get 3x minus 15 equals 7 plus x. All right, and then we want to subtract 7 on both sides. Or no, I'll do it the other way, I'm sorry. So I'll Yeah, I'll subtract the x on both sides, right? Yeah, I like to keep the x's on the left side of the equation, right? And then let's add 15 on both sides. All right, so then 3x minus x is going to be 2x. 7 plus 15 is 22, and then 2x divided by 2, 22 divided by 2 is going to get us our solution, right? So then we get x equals 22 divided by 2 is 11, right? So we got this as our answer, but we also need to check, right? Remember, you need to check for extraneous solutions, right? So here, when we plug in 11 here, obviously we're not going to get a 0, right? 11 squared is nowhere near 0. Same thing here, right? 11 squared again is not 0. Same thing here, right? 3 times 11 squared is not 0, right? So this solution works, right? This is our solution. All right. Let's do the same thing with number 20, right? Thankfully, this one has the same denominators as the last one, right? So let's just multiply the entire equation by 3x squared. All right. Multiplying by 3x squared is going to eliminate all the denominators, right? So distribute 3x squared to everything, and it's going to work out the same as the last one, right? So 3x squared times x minus 1 over 3x squared equals 3x squared over x squared minus 3x squared times 2x minus 8 over x squared. All right, and now we want to see what cancels, right? Over here, the 3x squared cancels out. We're just left with an x minus 1 equals, and then here the x squareds cancel out, so we're just left with 3. And then minus, over here that cancels out is an x squared, right? So we're left with a 3 times 2x minus 8. All right. And then same as before, right? We want to distribute this negative 3 to everything. So we get x minus 1 equals 3 and minus 6x plus 24. All right. All right, and now we just want to combine like terms and then move all the x's to one side. All right, so then 3 plus 24 is going to get us 27. All right, minus 6x equals x minus 1. And now let's get the x's to one side, so let's add 6x on both sides, and then add the 1 to the other side. All right, so then we get 7x equals 27 plus 1 is 28, and then divide both sides by 7, right? We should get x equals 4. All right, and then when you plug in 4 to the denominator, you're not going to get 0, right? Substituting 4 here, right? 3 times 4 squared is not 0, right? 4 squared is not 0, and 4 squared also is not 0, right? So this is our solution, right? And every single one of these where you see a variable in the denominator, you have to check for extraneous solutions, right? You don't want to lose points for not checking, right? You did all the math correct, but you didn't check, right? If it is a no solution and you don't write the no solution, you're not going to get full credit, right? Here it works, right? Because when we plug in 4, right, we don't get 0 in the denominator, right? But it's good that you check, right? Get into the habit of checking. All right, so let's knock out this last page. All right, so again, this last page is all going to be with variables in the denominator, right? Rational equations with variables in the denominator, right? So let's try a bunch of these. All right, so something like 21, right? You might see x squared plus 2x and the x, and you want to multiply by both of them, right? But with all of these, you want to make sure that everything is fully factored, right? To make sure you're not excessively multiplying, right? Because when you factor out an x from x squared plus 2x, right, we get x times x plus 2, right? Same thing here, x times x plus 2, right? And because x is in factor in all three of them, right, let's multiply this entire equation by x. And then because they share an x plus 2, let's multiply by x times x plus 2, right? That eliminates these denominators, but it also eliminates this x, right? So this is enough, right? You don't want to multiply by too many things, right? Maybe you're tempted to do x times x squared plus 2x, right? No, that's too much, right? Then you end up with a bigger equation than you need, right? So you don't want to do that. All right, so when we distribute x times x squared to this entire equation, we get x times x plus 2 over, and I'm going to write the factored expression, right? So I'm going to write x times x plus 2 on the bottom, and then plus 1 times x plus 2 is going to be x times x plus 2 over x. And then this equals 4 times x plus 2. All right, so 4 times x plus 2. All right, over, and then again, I'm going to write the factored expression, x times x plus 2. And then let's see what cancels here. Over here, the x times x plus 2, the entire thing cancels. Over here, the x cancels. And then over here, the x times x plus 2 cancels. Right, so when this all cancels, right, this just becomes a 1, right? Don't get tempted to write a 0, right? Even though it goes away, like, it doesn't disappear completely, right? You still need to write a 1, right? Anything divided by itself is 1. So we get 1 plus x plus 2 equals 4. All right. And then you want to combine like terms. 1 plus 2 is 3, so we get x plus 3 equals 4. All right, and then subtract 3 on both sides. So then we get x equals 4 minus 3 is 1. All right. And then when you plug in 1 into the denominator, right, do we get 0 anywhere, right? 1 squared plus 2 times 1, right? That's not going to be 0. And then when you replace this x with a 1, right, again, that's not going to be 0. And then same thing here, right? 1 squared plus 2 times 1 is not going to be 0. All right, so then we get x equals 1 is our answer, right? So again, always check your solutions. All right, this one's going to be a similar one, right? n plus 4, and then n squared plus 4n, right? We want to factor out an n from this n squared plus 4n, right? Just to make sure you're not excessively multiplying, right? Now, because we have an n plus 4 in all three of them, right, we're definitely going to multiply this equation by n plus 4, but we also need to cancel out this n, right? So to cancel out this n, let's just multiply an n with it as well. All right, and so just like before, right, let's distribute the n times n plus 4. All right, and then we get 2 times n plus 4 over n plus 4, and this equals 1 times anything is itself, right? So n times n plus 4 over n plus 4, and then minus, again, 1 times anything is itself, we can write n times n plus 4, and then on the bottom, I'm going to write the factored expression, right? So n times n plus 4. Right, that's the same as this n squared plus 4n. All right, and then just like the last one, let's see what cancels. Over here an n plus 4 cancels. Over here an n plus 4 cancels. And over here the entire thing cancels. All right, so we're just left with a 2n equals n minus, and then everything that cancels out here, this becomes a 1. All right, so then all you have to do here is subtract n on both sides. Right, and then 2n minus n is going to be n, and then n equals -1 is our answer, but we need to check, right? When we plug in a -1 here, -1 plus 4, right, that's 3, right? -1 plus 4, again, that's 3. And then -1 squared plus 4n, right, that's not going to get you 0, right? -1 squared is 1, plus 4 times -1 is going to be -4, and then that's going to give you a -3, right? So it's also not 0. As long as it's not 0, right, we have a solution. All right. And then something like 23, again, just like the last two, don't get tempted to multiply p plus 6, p plus 5, p squared plus 11, p plus 30, right? No, that's way too much, right? You want to factor p squared plus 11p plus 30, right? So it becomes p plus 5, p plus 6, right? What multiplies to 30 and adds to 11 is 5 and 6, right? And because these match, right, all you have to do, multiply this entire equation by p plus 5, p plus 6. All right, distribute this to everything, and then we're just left with a p plus 5, p plus 6 over p plus 6 equals, and then we have a p minus 4. Let's multiply that with the p plus 5, p plus 6 over p plus 5, p plus 6. All right. And then plus 6 also times p plus 5, p plus 6 over p plus 5. All right, so this is a big expression now, or a big equation now. Too many things, right? But lucky for us, majority of it cancels out, all right? So cancel out the p plus 6, p plus 5, p plus 6, and then a p plus 5. All right, so I know I said lucky for us. This wasn't luck, right? You're strategically picking, right, factors that when you multiply this entire expression cancels out the denominator. Right? Again, like I keep saying, the whole point of multiplying the entire equation is to get rid of the denominator. All right, and then plus 6 times p plus 6. All right, and then we just solve as normal, right? Distribute the 6 to everything. So then we get p plus 5 equals p minus 4 plus 6p plus 36. All right, combine like terms, right? P plus 6p gets you 7p, and then minus 4 plus 36 is going to get you plus 32. All right, equals p plus 5. All right, you can subtract 7p on both sides. And then we can subtract the 5 on both sides. And then p minus 7p is going to get us minus 6p. And then on the other side, we're left with a 27. All right, and then we want to divide both sides by negative 6. So then we get p equals 27 and negative 6 share a factor of 3, right? So this becomes negative 9 over 2, I believe. Yeah, divide them both by 3, we get negative 9 over 2. And then when you plug it into the denominator, do you get 0 anywhere? Right, you shouldn't, right? So negative 9 over 2 plus 6, that's not 0. Same thing with this one right here, negative 9 over 2 plus 5, that's also not 0. Right, and because these are factors, and we just plugged it in, then they're not going to be 0 either. All right, good. Now let's try the same thing for 24, 25, and 26, right? So there's 3 left. All right, same thing here, right? Let's factor out the x from x squared plus 2x. All right, so we get x times x plus 2. All right, multiply the entire equation by x times x plus 2. All right, so then we get 6x times x plus 2 over x equals x plus 3 times x plus 2 over x times x plus 2 minus 1, or 1 times anything is itself. So I'm just going to write x times x plus 2 over x. All right, and now let's start canceling. All right, x and x cancel out. X plus 2, and x and x cancel out. And over here, an x and an x cancel out. So then we're just left with a 6 times x plus 2 equals x plus 3 minus x plus 2. All right, don't forget to write the x plus 2 in parentheses. We're subtracting the entire expression. All right, so let's distribute the minus and let's distribute the 6. So then we get 6x plus 12 equals x plus 3 minus x minus 2. All right, x and x cancel out here because they're like terms. And then 3 minus 2 should just get you 1. So we get 6x plus 12 equals 3 minus 2 is 1. Now let's subtract the 12 on both sides. All right, so then we get 6x equals 1 minus 12 is negative 11. All right, divide both sides by 6. You get x equals negative 11 over 6. All right, and then plugging it back into the denominator here, right, it's not going to get us a 0 anywhere, right? So this is our solution. All right, now we want to do the same thing with this one, right? Factor the k squared minus 6k plus 5. So we're going to get a k minus 5, k minus 1. Same thing here, k minus 5, k minus 1. All right, and now let's multiply this entire equation by k minus 5 times k minus 1. Right, and that's because that's the smallest amount that we need to multiply to get rid of the denominator. Right, there's a k minus 1 here, and that's accounted for here. Right, and the k minus 5 is accounted for as well. All right, so when we multiply this entire equation by k minus 5, k minus 1, right, we get 6 times k minus 5, k minus 1 over, and then I'm going to write the factored expression, right? So k minus 5, k minus 1. And then plus 4, k minus 5, k minus 1 over, and then this one's just k minus 1 equals k minus 5, k minus 1 over, I'm going to write the factored expression again, right? K minus 5, k minus 1. All right, and then simplify and cancel things, right? So cancel all of these. Over here, the k minus 1 cancels, and over here, everything cancels. Right, so we're just left with 6 plus 4 times k minus 5 equals, and then over here, you're just left with a 1. Again, don't make the mistake of writing 0, right? Just because you cancel it all out doesn't mean it disappears, right? It divides to 1. All right, and now distribute the 4. We get 6 plus 4k minus 20, right, equals 1. Combine like terms, right? So we get 6 minus 20 is negative 14 plus 4k equals 1, right? Add the 14 on both sides. Then we get 4k equals 15, right? And then divide both sides by 4, we get k equals 15 over 4. And then again, when we plug it into the denominator, right, we're not going to see a 0 anywhere, right? So this is a good solution. All right, and let's try this last one, right? So I'm giving you a bunch of examples like this so that you can practice it, right? This won't make up a majority of your test, but still, right? I don't want you to neglect it, right? That's why I give you this much practice, right? So that you get more comfortable doing these kinds of problems, right? So let's factor the denominator, right? Just like before, right? What multiplies to 20 and adds to 9 is going to be k plus 5, k plus 4. All right, k plus 5, and then k plus 4. All right, and this k plus 4 is accounted for by these other two factors, right? So let's multiply this entire equation by k plus 5 and k minus 4, or k plus 4, sorry. All right, so then we get k plus 2, k plus 5, k plus 4, right? If you see things that cancel out right away, right? So maybe you've been practicing these enough and you see immediately what cancels out. If you can immediately see what cancels out, then you don't need to write all of these steps, right? Again, and I said it in class too, right? I'm writing it out so that you can see what cancels out, right? But it's not completely necessary. Like maybe at this step, right? You can see that k plus 5 and k plus 4 are going to cancel out with this k plus 5 and k plus 4. So you don't need to write all of this and you're just going to write the 1 right away, right? That's perfectly fine, all right? But I'm just going to keep writing it. All right, and then equals 3 times k plus 5, k plus 4 over k plus 4. All right, and now lots of things cancel here, right? K plus 5 cancels, k plus 4. Over here, everything cancels, and over here, the k plus 4 cancels. All right, so we're just left with a k plus 2 minus, and then on this side, we're left with a 1. Again, don't make the mistake of writing 0, right? And this equals 3 times k plus 5. Distribute the 3 to everything. We get, on this side, we can combine like terms, right? 2 minus 1 gets you 1. So we get k plus 1 equals, and then on this side, we can do 3k plus 15. All right. And now let's bring everything to one side, right? So we can subtract 1 and then subtract 3k. All right. And then k minus 3k is negative 2k. And this is equal to 15 minus 1 is 14. And let's divide both sides by negative 2. All right. Cancel these out, and then we get k equals 14 divided by negative 2 is negative 7. All right. And then when you plug it back into the denominator, right, you're not going to see a 0 anywhere, right? Negative 7 plus 5, right, that's not 0. Negative 7 plus 4, that's not 0, right? So we're good, right? Right, so none of these were really any interesting cases, right, where we get an extraneous solution. There's more examples like that in the lesson video, right? So the 1.2b video has some examples, right? And you have some in your notes, right? So if you wanted to see what those look like, find them in those videos, right? But otherwise, this is your entire review, right? Hope this helps.